Hi everyone, I'm Ranadeep, and today we'll be talking about unit tests and continuous integration. So, continuous integration is also known as CI, and it's often called also CI/CD together. So, we'll talk about how it is and how it's helpful to push your code and maintain its good quality. So, this is the overview for today. We talk about CI, we talk about CI pipeline. There'll be a good demo following. But before that, what you actually test in continuous integration are unit tests. So unit tests actually tell you the your code's capability of running successfully. So there are multiple unit tests that you can do to just check, like, does the function's result, is that a type of list? If it's a list, is it 20 different items, 20 different movies that you're recommending? And a lot of these you can code using assert statements or other testing functions that actually import your recommender function. You can import that, call it, and see what the result is, and just check the types and everything. So you're basically testing the integration of your code. Like, does it all work well together? So that's why you want to test your functions, because you want to ensure that one function is giving the expected result that the other function is expecting. So there are multiple frameworks for this. PyTest, of course, is the a very famous and recommended one. We'll go over in the demo like how you code it using PyTest, and it's so C as the first step for CI/CD pipelines, and we'll talk about more in the demo. So there are some good practices that you can do when you write your code. So some of these are: give descriptive test name. So if your function is named recommend dot, like your function is called recommend, then your test function should be called test recommend. If your testing function is only testing a specific thing, so maybe call it test recommend list size or test recommend return value. So you can divide it multiple ways, um, and then each test should be independent. Uh, Now, each, as we spoke about, because you're testing multiple things from your functions, having multiple different test functions test separate things like return types, return values, length of return values. All of these should be independently covered. And then when you also run your test with PyTest, you will see that it should also have good code coverage. So by good code coverage, we mean checking all of your functions, checking all of your code. It should give you like 90%, 95% um, test coverage, if not 100%. And then we'll also with CI, we'll teach you a way of how do you test your functionality automatically on every code push. But also there's some limitations. Using unit tests alone, it does not cover all the possible scenarios you could have with integration problems. Those are more niche problems, but in general, it can do a lot to help you. And then because you're writing a test manually for each case, if you don't write a test for something, you won't be able to catch it. And then, yeah, since it's milestone 2, you'll see that you're going to be writing these tests retroactively. It's not really gonna. It's difficult to put it in your code, but if you start from scratch, if you start a new project and you retroactively have a list of test functions that you're also writing, it'll be really easy to maintain that. Then, yeah, let's talk about continuous integration. So, continuous integration is a sequence of checks that a system has to go through before it's deployed. Usually you'll see this as a script, which once you push your code to GitHub, it'll do these 4 or 5 checks in order. So it'll like maybe compile your code, it'll check for unit tests, it might even check for metrics or whatnot. But the main thing is it just checks the pipeline, it checks all the functions. And the goal is to like reduce the time taken to push features. So instead of you doing a pull request and merging your features and the person accepting the pull request, they won't have to spend a lot of time checking the integration problems. They know that if the continuous integration test pass, it's much more likely that your code will run and won't break anything. So the accepting the pull request without a code review is much easy. Not only for your milestones, but for your like corporate work life later on. And the CI pipeline is just a set of stages in an automated script, as we spoke about. The stages are like when you push your code, the script runs to set up the environment for your code. So it'll do the pip installs from your requirements or something else. It'll build the code. If it's a C++ code, it needs to be compiled. It will do the static checks to ensure, like, it's up to you what you code, but any specific version check or whatever. Then there's unit test. So unit test checks the functionality. Integration checks the functionality of the whole code. Like, does it work together as a bundle? And then possibly packaging the software. So If you want to containerize it into a Docker for future deployment, so it could possibly do that too. For machine learning models, you could even do more things. So, such as we spoke about offline evaluation, collecting more data, or a bunch of that could be part of your CI pipeline, because at the end of the day, you want to test how your new model is also doing. So some CI tools that are out there are GitHub Actions. So they're recommended for easy flow. But what also we'll be talking about is Circle CI, because GitHub Actions, although really easy to use, you should be using it for personal projects. There is a limit per repository of 2000 minutes per month. And we expect, because of the class size, that we'll be over with the 2000 minutes. So although it says recommended for GitHub Actions, it's good to learn that in this recitation. But we'll also go over Circle CI and how that's awesome. So maybe think of using Circle CI instead for your repo, because if GitHub Action goes down, we might not accept that, it's okay for it to go down because it was GitHub Actions, because, you've been warned. It's a great thing, but not the best in this case. Yeah, so here's the demo. The sample code has been shared with you, but it's also at this link. The contents of this we'll cover would be like walking through the code and PyTest implementation and more. Awesome. So we're here in the VS Code for the demo. So this is the repository that's already been shared with you. If you open README, you can see all the setup and commands. So once you clone it, once you install the requirements, you can just run these tests. So let's go through the code where it is. So let's say I'm telling you to run this test. The main test here is main.py. So there are a few functions. Hello world just prints hello world. There's recommend. So I have a movie CSV, and I'm saying like just randomly sample some number of movies, let's say 5, and then print out the values and join them with a comma separated list. Something like what you do, right? There's also train model. So this is actually not a model; it's a dummy function to just sleep for a random amount of time, and to basically simulate how model training would look like. So if we do run this file, let's say python main.py, we can see it just says hello world training model, and the training took 2.02 seconds, 02 seconds. And this is the list of movies we got. So something very similar that you would do, right? So let's see the test that we wrote. So there's a corresponding file, test.main. So tests are very simple. So you just write assert statements. So for hello world, if you remember, let me open it parallelly. For hello world, because the return was hello world, the functionality should be of the type string, like the return value. You also know the return value is exactly hello world. So this is a special function, so you can see that. So you have 2 assert statements in this case. There's also test recommended. So test recommend. So in this case, that the return type should be string. And then because it's a list, like if you separate with commas, it should be of the type num movies. And because num movies given was 5, like you sent that, like it should be of that value. If not, it should throw error. Now, the way you see and run this is by doing this. So when you do, let's say for running PyTest, it's this line. So coverage run PyTest, and basically this line, the pipe and T, basically say that all print it out in my terminal and also make it send the data to this report. So let's say we run this. So we see, okay, 100%, the test passed. So that's awesome. Let's look at our reports. So in our reports, because it's unit test report, we can see what it looked like. So again, the same thing. So it's good to store that for some reasons, as you'll see in the CI pipeline. Similarly, we can even run the coverage report. So in this case, you see like our main.py, it was only 53% was covered. And these lines were even missing. So that's not very good. But we can also see this in a cool HTML view. So when you do coverage HTML, it says, all right, saved it to HTML coverage. And if you happen to open this one, so let's reveal it in my folder. Awesome. So opening it, you can see something very similar, but it's a more interactive UI. So let's say you go into main.py, it shows you what was covered, what was not covered. So we didn't write any unit test for our train model, and that's why it says that all of this was missing. Usually it's okay to have name equal to main missing, because of course it's only supposed to be triggered when your file is triggered. So some amount of loss coverage is okay. Like that's why we don't expect 100%, but it should be up in the high 90s. Like as long as this is everything except the main function is covered, it's all good. Now coming to this, as we saw, like, our test pass, but let's say if we have our test be a little different. So instead of hello world, we just expect hello. Let's see how that affects our coverage. So if we run the unit test, in this case, it tells us that it failed, that, you got the return value is hello world, but you only expected hello. So this is the kind of errors you can expect to see. But yeah, let's go back. Now let's look at model training and evaluation. So that was an example of PyTest. It's very simple. Like you just write assert statements in a separate file called test.test_main. When you run this file, PyTest, it just knows, like looking in your repository where you're running, that, okay, if it's test_main, look for a main.py. Like it has associated functions with it. So that's how it identifies. So it's pretty automatic and pretty nice. Better than the unit test library, in my opinion. And then looking at model training and evaluation. So because that's also a part you need to know, that since you're developing a machine learning system, you need to also evaluate the model training. So in main.py, as we saw, there is like a train model function. So let's see, how do we test that? So if we do run it, as we saw earlier before, that it simulates some kind of training. It spits out some training time. So in this case, right, roughly 4 seconds, and it gave us these 5 movies. Now we stored it in our reports, model train report. We could see like how much time it took. So that's only good for logging. But if you now that you've trained your model, you want to do offline evaluation, you can do something very similar. You can just see, like in offline eval, what it's doing. Here you would have some kind of evaluation, maybe RMSE, maybe some other metrics. It's totally up to the model you use, what kind of metrics you use. But in this case, it's just a random number, random percentage number. So let's say my model accuracy was just predicted from 0 to 100%. It happened to predict 66%, which is not bad, but okay, it's random. So yeah, you kind of run a script to evaluate this. Now, where it all comes together is in continuous integration. So for GitHub Actions, it's actually very easy. In your directory, you create a .github hidden folder, which has a workflows folder, and then you have a YAML file. So if you remember from an earlier recitation, YAML just means yet another markup language. So the format is something like this. So as we spoke about, the CI pipeline should automatically be triggered every time you do a push to your GitHub repository. In this case, the format is you just give it a name. You tell it that every time there's a push or a pull request, run the integration test. Then all of this is like standard language for this, for YAML. Use some of the actions. So GitHub Actions has pre-built actions. So like there's checkout, there's setup. So it sets up all the environment. You tell it the Python version, 3.10 in this case, install packages. So for every step you do in your CI pipeline, you give it a name and you give it run commands. So it could be multiple lines too. So what we're doing is, here is you're running the requirements, you're running the coverage test report, unit tests and coverage. Then what you're also doing is you're saving the report. So whatever report that was generated, you are uploading the artifact and you're saving that. So we'll show you how that's saved and why that's important. And you're saying, when you save this report, save it for 10 days. It could be lower or higher, but usually you don't really want it that long because you're committing very often. Similarly, there's also test model. This is the earlier continuous integration plus your model evaluation. So here there's a cron job. So cron job is like a pre-scheduled job. There's a predefined syntax for it, which is like seconds, minutes, hours, days, and day of the week. What this means is day divided by 2. That means every 2 hours, run the job. So every 2 hours, it'll run your model training and evaluation. So just like the earlier steps, you do the PyTest. If that fails, it should not run the other things. So let's say you train your SVD model. It generates the report. It generates the offline report with your metrics, and then it stores all your reports for 10 days. Now, let me show you how that actually looks in GitHub Actions. So when you go to your GitHub repo, you have your workflows section. You can just go into your Actions tab. This shows you all your actions that have run. So, or have been running. So let's say in this case, CI PyTest, which runs every 2 hours, that has been faithfully running every 2 hours as we see. But let's look at some other action. So this is what was triggered by the code push I did. So when you go into the thing, it shows you, okay, it ran for 25 seconds. It had some warning. It had these files also. So if you want to see your coverage reports, it's just right here. And if you download it and view it, let me pull that up. It looks something like this. So it shows you what your coverage report was like. So just something you expect. If you go inside the test, you can even see more details. You can see it set up a job, it installed the packages, and whatever names that you gave in your YAML file, all of those come here, and you can expand to see more details. Similarly, the every 2-hour evaluation that runs, very similar, but now instead it has 4 files. You can manually even delete it. You want more information, you can go in here. I'm not sure if I have a failed test here to show you, but yeah, usually you won't really have a failed test, but if there is, it'll warn you. So it'll be like a red X mark. All right, awesome. So in the demo, as you saw, GitHub Actions tab is there. Your scheduled model, your Git push are shown like that. Then there's your job summary, like if it was a success, how much time it took, your generated reports, and then detailed job steps. So if you click on any, you can see more details. Now, some of the CI pipeline qualities that you're aiming for is that every time your code runs, the CI pipeline should run the same test. So it's the same scientific method that you want to test in the same environment. So you're using the same Python version as your code should. You're using the same requirements with versions fixed and whatnot. Your CI pipeline should also be fault tolerant. So as we saw when we did the model evaluation, you did the unit test first and then you tested the model, because if something else has to fail, that should fail first. And yeah, like there are a bunch of other things which are important. And of course, like the last thing, if you do plan to use GitHub Actions, that you should make it really quick. The more time you spend on the GitHub Actions, the more CPU time you take, the more limited you are. So try to make it quick and efficient. And yeah, that's it for the demo. All the links are here, but we really recommend using Circle CI. Let me show you what it's like. There's a YouTube video also of it, like how to use it. Very helpful. But yeah, for this assignment, we'll recommend using Circle CI. So yeah, this is what Circle CI looks like. You can go to the website, you can sign in. It's pretty much like what GitHub Actions does, except that having a tab here, every time you push your code, it runs it separately. So there's a .circleci folder here. Your config.yaml, it's a little different. You can see in the YouTube video attached. So there's a YouTube tutorial. You can go and check that out. It's very good. It's something even I refer to. And it explains everything really well. When you do sign up on Circle CI, you can select your user ID. You can select the repository that you want. And then over here, you'll have to select like a branch also. So when you select for main, it'll look for the config YAML. So you need to have that beforehand. And then you can just set up your project. And once that's done, your project, like your GitHub repo will also show this. So if you go to your GitHub repo now, yeah. So as you see, it's very well integrated with GitHub. So it shows like my GitHub Actions was successful, but my Circle CI did not run. So that's because the YAML file that I have, that's not compatible with it yet. But if you look at the YouTube tutorial, you'll be good to go. So yeah, that's it, folks. Thank you for joining in. And please do ask on Slack or Office hours if you have any doubts, if you have any troubles getting on with it. So yeah, thank you.